Hello there. Today we'll be doing count binary substrings. Given the binary string S, return the number of non-empty substrings that have the same number of zeros and ones, and all the zeros and all the ones in the substring are grouped consecutively. Substrings that occur multiple times are counted the number of times they occur. So in this example, we have 0, 1 1 0 0 1 1, and the output is 6. The reason why it is 6 is because of the way we how do you say, we separate out these items. So how do we separate out these items? So first of all, these items can be separated out whenever it swaps between zeros and ones. So for every 2 zeros, you can have 2 ones, and that would count as 2. Here you have 2 ones, and then you have 2 zeros, that would count as 2. 2 zeros and 2 ones, that would count as 2. So that would be a total of 6 items. In this particular example here, they seem to suggest something a little different. The difference is that they check this item here, and they check this item here for a total of 6 substrings. As you can see, this substring has at least 2 items, and this substring has at least 2 items included inside. See, as you can see, this substring has this included inside the substring. So for every wider bracket of a substring, let's say 3, there's actually 3 substrings inside of 3. We don't actually have to do this. So what we want to do only is to count the number of times we see to zeros, and then we swap over to ones, and then we take the minimum of the 2 and add it to our answer. Then we swap the previous to now the previous is now the current of the ones, and then we take a current and start counting the zeros afterwards. And once we have that swap again, we will count the minimum between the two, and we can create that the swap. You might ask, why will we use the minimum? The minimum is because even if you have 3 zeros and 2 ones, you can only capture the 2 zeros and 2 ones together as a substring that has equal number of consecutive ones and zeros. Okay, less talking, more coding. All right, let's go. So the answer is going to be, we're going to start that at 0. The previous item, start that at 0 because there is nothing previous. And current, we're going to start that at 1 because we want to have 1 count. It doesn't matter if it's 1 or 0, doesn't matter what it is. We're going to start counting it as that. Whatever it is, we're going to see if it's the next item is going to be the same as the previous item. The 1 is included here, and the length of the s is what we're going to do. So if s of I minus 1 does not equal to the s of I, so they're no longer equal, the answer is going to plus equals the minimum of the previous and the current. And then we're going to move the current to the previous, because we are going to keep those numbers around so that we can count the next one. The current is now going to be equal to 1. Otherwise, we're going to keep moving the current and increasing its number so that we can count which one's lesser. Once we're done so, we can return the answer plus the minimum of the previous and the current. The reason why we need to do this is because once we hit the end, there's no swap. And when there's no swap, we don't add that little chunk, last bit, into our answer. So we have to do this so we can add it to the end. Let's run our code. Oh, we have a runtime error. Looks like we have a... Okay. Looks good. And let's submit. Perfect. And that's how we solve the count binary substrings. Well, that is all for today. If you have any questions, comment below. If you enjoyed the video, like and subscribe. And if you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.